I will give you some examples of current evolution today. Since you know that evolution is a long process, it happens gradually, but a type of evolution is there which has happened in recent times, and that evolution is called current evolution. I will give you one example. The best example of current evolution is industrial Melanism. Industrial Melanism. The evolution was shown by a type of insect which were named as peppered moths. Peppered moths. These are insects type of butterflies which are placed in class Insecta of phylum Arthropoda, and their one of the main features is that they can fly. And the type of evolution, industrial Melanism, occurred in UK or Britain, we call it, after 1845. So it is a recent evolution. It happened after 1845. Now, the pepper moths are insects and their main enemy, their main predators are birds. Birds like to eat them. And moths also, by fighting to protect themselves. For the purpose, the prey often shows some features in which the color matches with the background. That's called camouflage. Most of the these preys, you know, that which are eaten by other animals, they try to merge with the background so that they cannot be easily detected. Now these pepper moths, they also the color was light gray. They were light gray colored, and they protected themselves by sitting on lichens. Let this be lichen. Lichen, you know, lichen is association of an algae and a fungus. A fungus and an algae, they join together by the process, you know, called symbiosis, and they form a new type which is called a lichen. You know that algae are green and algae is green. A fungus, it is usually non-green, and a green has the property of photosynthesis if light is available, but non-green cannot. It cannot synthesize food. A fungus, this fungus has a property, it is hygroscopic. Hygroscopic means that it can absorb moisture from the water. Since you know, for photosynthesis, green chlorophyll is important, and water is also important. Now what they do, this algae and fungi make an association which is called lichen. Algae being green can synthesize food if light is available, and fungus absorbs water from the moisture from the atmosphere and provides it to algae, which can synthesize the food, and both they can meet their requirements, and this is symbiosis. Now, by the help of this feature, by the help of this property, lichen can grow anywhere. They need not to grow on the soil because fungus can absorb water from the moisture also. So they can grow on rocks, they can grow on walls, they can grow on barren places. Now, usually in UK, those lichens which grow on rocks or which grow on walls, their color usually matched with the pepper moths. So, pepper moths usually hide themselves on the lichens like this. This is a pepper moth, and this is lichen. Pepper moth was grey colored, and lichen, it matched with the lichens. The same color somewhat was of lichens, and it was not easily detected by the birds, so it easily hid itself and it was protected. So this was a protective mechanism and it provides camouflage. Now, this was up to 1845. After 1845, what happened? In England, there was a high industrial growth. High industrial growth, and you know that industries were working on the petroleum products, diesel, etc., and they emit a lot of carbon dioxide along with smoke. Since high industrial growth was there, industrial explosion was there, and a lot of carbon dioxide, lot of smoke was emitted, and there was air pollution. And this smoke, it settled on the lichens also, because it settled down there, smoke being higher particles, they can settle, and the lichens were in due course of time converted to black due to smoke. So smoke was responsible for modification, the change of color in lichens from their original color to black. Now, at that time moths were light grey, the background lichen was black, so these were easily detectable by the predators, that means birds, and they were eaten. Now, for the purpose of survival, because evolution is actually a survival, it provides best survival to the animals, to change by modifying themselves, by changing themselves. So, what moths did, they also modified their color from light grey to black, because the background lichens were black, they also modified their color from light grey to black. Now how? What was the mechanism? Actually, in animals, the black color is produced by the deposition of a pigment called melanin. And for the generation of melanin, or for the deposition of melanin, genes are responsible. Initially, their genes were not either producing melanin or depositing melanin. But now, since they needed melanin for their survival to convert their body color into black, they begin to produce more quantity of melanin and their deposition, so they have to modify their genes, or they have to modify their chromosomes. There was a mutation in the chromosomes, and the genes were modified and melanin was produced. Then this melanin was deposited over the body of the this moth, and moths became black color, and they can easily now hide themselves on the lichens, because lichens were also black color. So up to 1895, the species was modified into black. Initially it was light grey. Now up to 1895, the evolution was complete. No light grey moths were available, only black moths were available. So a new species emerged. First it was light grey species, now it was black colored species. And you know that this emergence of new species is called evolution. Since the main force behind the evolution was industries. If industries were not at that time, the lichens might have their own color, and the moths did not. They would not have undergone this type of evolution. So this type of evolution was named as industrial melanism. Industrial growth and melanism means that the light colored moths were converted into black colored moths due to deposition and deposition of more and more melanin. For that, the genes were responsible, those were modified, and mutation or modification of gene is an important factor of evolution, and this is the best example of industrial melanism.